Hello students, welcome back. We went through a couple of videos about chain rule and the use of chain rule. Now let's talk about how to combine chain rule with other derivative rules, namely product rule and quotient rule alongside a chain rule. They can be done in really multiple fashion, and there are a lot of problems like these, and I intend to assign many of them in WebAssign as well as handwritten homework problem set. Let's go over to some problems here. How to handle this derivative problem? What is the outer structure? See, I emphasize outside in. In calculus, outside first and then you go in. So it is important you figure out the outer structure first. Outer structure is the product rule here. This times that. So you gotta remember the product rule, which is u prime v plus u v prime. Okay, you can do different order, uv prime plus vu prime or whatever order. My module is doing this one, so let me follow my convention here. Okay, u prime means this is a derivative, isn't it? So we'll have to take the derivative here. And then v is nothing more than this function, so we just copy and paste. And then here u is just copy and paste. And then multiply by the derivative. So that's the outer structure. And then take a deep breath. When you're ready, you can begin filling those up, or maybe you can slow down even further. Let's do it this way. Put the dots in there, and then take a separate step. And then let's fill out those brackets here in the second step. Slowing down really helps cutting down unnecessary mistakes. So try this if you think you are mistake prone. Okay, the derivative of the first function, it is 6x plus 2. Now this is v prime u. How about the derivative of the second function? That's the derivative of this square root, and then there's something inside the square root, so it looks like you'll have to use the chain rule here. Ready for chain rule. Outside 1/2, subtract 1 from the power, that's step 1. Inside stay the same, so nothing changes here. 5x cubed minus log of x. Okay, and then we have to multiply derivative of the inside. And if you're uncomfortable, let's just put ... and move on, but if you feel okay, just go ahead with the derivative. This is 15x squared minus 1 over x. That'll complete the problem. So this is u prime v, and this is u, and this big part is v prime, the chain rule part. You can do this in a single step if you want to, yeah, but I would strongly recommend you to break down into either 2 or 3 steps. Why? To cut down mistakes. Okay, let's go to the next example here. By the way, the answer key is posted, so no reason to keep duplicate here. So let's remove this now. Let's go over to the second problem here. We have power function, square root is power, and then inside we have a quotient rule. So what is the outer structure? outer structure is outer function is power function. So the outer structure is chain rule. Here, outer structure was product rule. So product rule first, and then we went to chain rule. This is the other way around. Chain rule first. J prime of x is, okay, outer function 1/2, and then subtract 1 from the power, and we have to multiply the derivative of the inside. That's the structure. What goes here? Step 2 of the chain rule. Inside stays the same. So let's just copy. And then let's consider the derivative of the inside a bit later. Let's keep it as dot 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 provisionally, at least temporarily. And then let's go over to the next line, and then let's consider the derivative inside as a separate problem. You're going to need it because there's going to be a quotient rule. Okay, let's work out the derivative of the inside, and oh boy, that is expected to be rough because that's going to be a quotient rule. How does that work? Denominator squared, and then the numerator is u prime v minus u u prime v minus u v prime. That's the structure of the quotient rule. Excuse me, I'd better increase the font so that you guys can read this a little bit better. Okay, so u prime v minus u v prime. So okay, u prime, let's consider the derivative computation a bit later, and then let's just copy and paste the denominator here, u cubed minus 3u, and then let's do the same thing here. The numerator is u squared plus 2u, and then this is dot 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 the derivative of the denominator, and let's consider this in the next step. Okay, shall we finish this problem? Let's go ahead and finish this problem. The derivative of the numerator is 2u plus 2, and v prime minus u v prime, the derivative of denominator. What is the derivative of this 3u squared minus 3? Okay, does it look okay? Step 1, the chain rule. The derivative of the outer function inside stay the same, and then the derivative of the inside is complicated, so let's put dot dot dot, and then just take a deep breath, regard it as a separate new problem, and let's just move on. Next, all stay the same, and then let's work out the derivative of this quotient. It's quotient rule, what can I say? So it's two maybe multiple step problem. The denominator squared, and then you get u prime v minus u v prime. Sorry, there are too many u's and v's, so it can be a little bit confusing. And derivative of denominator times, here we go again. Derivative of numerator times denominator minus numerator times derivative of denominator. Oh, it's hard. Anyway, even though the characters overlap with each other, just use usual quotient rule, u prime v minus u v prime over v squared. And then let's see, u prime, the derivative of numerator, 2u plus 2, and then v prime, the derivative of denominator. There you go, 3u squared minus 3, and that'll complete the problem. In this kind of problem, I really strongly recommend you to do this in multiple steps, like this 3-step, or if necessary even further. It is not wrong trying to do this in a single step, but you're inviting yourself to possible mistakes or even likely mistake. So it is highly discouraged. And then it is possible to simplify further and whether to do that or not is completely optional. I prefer not to. Now if you do simplification without any of all these work, how much you're gonna get? 30% of the problem maximum, quite possibly even lower than that. It is very important you have all those intermediate steps according to chain rule, product rule, or quotient rule. The answer key is over here, so there's no reason to keep the duplicate. How about the next problem? Do we have enough time for the next problem? Well, whether we are ready or not, let's go ahead and do that. Maybe I'll speed up a little bit. Okay, let me increase the font. Okay, the outer structure is clearly the quotient rule. This over that. So let's put this into the structure of quotient rule, denominator squared, and then this is u prime v minus u v prime. That's the structure of the quotient rule, isn't it? The derivative of the numerator and then this is just denominators, so you don't really have to do anything. Just copy and paste here. And then the numerator times the derivative of the denominator, and I guess that completes the step 1, the quotient rule part, the outer structure of the quotient rule. Now in each of these ... you have to work out appropriate chain rule here. Excuse me, let me increase the font. Okay, alright. Let's take the derivative of the numerator and put it over here. Take the derivative of denominator, put it over there according to the structure of the quotient rule. Ready? Let's go. The derivative of the numerator, 3y squared plus, oh, here comes a composite function. So by chain rule, 1/2 comes out, and subtracting 1/2 from the power, and then we have to have the chain part and inside part. What's the inside? Inside always stay the same. Ooh, okay, maybe font was too big. And then the derivative of the inside. Okay, that completes the derivative of the numerator. What do you think? Can you do it? Or do we need separate steps to break this one down? Okay, let's work on the next one. You can do it together, but I decided not to. Okay, let's work out the derivative of the denominator here. And the denominator is like this. Okay, alright, derivative of 2y is 2 minus, here comes a chain rule again, the derivative of this logarithm. Let's see, what's the derivative of log function? 1 over x, isn't it? So 1 over that thing, 1 over, okay, times, we have to multiply the derivative of the inside. What's the derivative of the inside? 2y. And I'll say this completes the problem. You can simplify if you want to a little bit, especially the last one over here, multiplying by 2y. So multiplication goes to the numerator like this, And that's about it. Any further simplification, I don't think that is necessary. I think it's better not to.